Hi, and welcome to the 9th lecture of Introductory Astronomy. Today we'll be going out into the outer solar system again. This time, instead of Jupiter and Uranus, we'll be doing Saturn and Neptune. And one might think that as you go out to the outer solar system, you'd be pretty much seeing boring objects, boring, not well-lit objects. But there's some really strange stuff out there. And there have been some spacecraft that have been zipping through the solar system in the past, 30 years or so, that have really caught some really cool vistas and opened up some puzzles as to what happens in the outer solar system. So one of them is this picture right here that was taken, has something to do with Saturn or Neptune. And this is a strange object. And this object is in the outer solar system near Saturn or Neptune. And we didn't expect that this object would look like this. And we'll talk about it later this lecture. What is this? What's going on here? First, the legally obligatory slides. This is Physics 1600 is the course official label. It is Introductory Astronomy, a course taught about the universe at Michigan Tech. And today, as I said, we're doing Saturn and Neptune. Next time, we will be doing Pluto, whatever that is, dwarf planet, which is what it might be, other dwarf planets, and comets. So this is taking place at Michigan Tech in Michigan, surprisingly enough. I am Robert Nemiroff, and you can take this class. You can see the lectures of this class through iTunes, and we're still working on the getting it just generally available through a place like learnoutloud.com, but not yet re-available through there. But just load iTunes onto some computer and go for it there. Still available there. If you're here at Michigan Tech and you want credit, go to courses.mtu.edu. And here at Michigan Tech, you never have to attend class. You never have to see my obnoxious face in person. You can just say mean things to the screen, and I'll never know. I don't know. Okay. So what is it responsible for in this freewheeling world of video material, video classes? You're responsible for things that I say, but only the correct version of things that I say, which is I'm usually pretty correct. You're responsible for the listed Wikipedia entries that are listed each class, but not if they contain higher math, because this is not a class that involves higher math. You're involved for every astronomy picture of the day posted during the semester, and I will be reviewing after this lecture the last 7, including today's. To get credit, it would be advisable to do the quizzes, of which the first 4 are already due, and the 5th one, called a homework, will be released later today. Again, to do this, go to courses.mtu.edu. If you're trying to go to courses.mtu.edu, but you're not at this university, you'll just hit some kind of place where it asks you for password, username, and password, and you won't have one, so you can't go on. You don't need that to learn the material. Knowledge is free. Credits cost money, so you can learn all the material without doing any of this. Okay, the Wikipedia entries are Saturn, rings of Saturn. Titan, at this point, they break it off. It's interesting that Wikipedia doesn't confuse the word Saturn with like the car Saturn. It knows immediately you're talking about the planet. But if you go to Titan, you have to tell it that you're talking about the moon of Titan. Enceladus, an interesting moon of Saturn getting a lot of play. Cassini-Huygens, a spacecraft which landed on Titan. And Neptune. Please look up Neptune. All right, same slide as last time, pretty much. So this is the week of Jovian planets. Jupiter, Saturn, Uranus, and Neptune. These are the largest, most massive planets in the solar system. Each of them has rings, each of them has many, many moons, and each of them has an expansive and thick gaseous atmosphere. So you can go outside many times and see Saturn. I don't think it's easily visible at sunset these days, but here in 2005, you could see this is the band of the ecliptic right here. The plane that the planets orbit the sun, and the closest planet to the sun and the closest planet here is Mercury. Hard to see usually. Venus, usually quite bright, and here it's not that Jupiter has been destroyed and taken away from our solar system by marauding aliens. It's just not in this part of the sky. So it can be anywhere in the ecliptic, and the closest to this part of the sky is Saturn. at this point. So there you see that on this night in 2004, it wasn't difficult to go out in sunset and see Saturn. Here's a more recent version. This was taken in 2008, July. So this is a crescent moon. And I need my notes because I don't remember where it was. Let's see. I believe that Saturn there's 3 dim dots here that you really have to look closely to see. And these dots, according to my notes, are, I believe it is Saturn on the upper left. And then Mars. So you can see Saturn and Mars are roughly the same brightness. And then finally, there's something that's pretending to be a planet, but not. It's a star. And that star happens to be Regulus, which is, last time I checked, not a member of the solar system. But we like it anyway. And then, of course, there's the planet Earth. All right, Saturn as a planet. It is the second largest one after Jupiter. It is 9.5 times the diameter of the Earth. Its diameter, it's also 9.5 times further out from the sun than the Earth. It takes roughly 29.5, roughly 30 years to go all the way around the sun, that would be one Saturnian year, be one Earth year. Saturn is not very dense. It's got a very fluffy atmosphere, a very fluffy outer part. So the average density is actually less than water. Saturn's been visited by several spacecraft. In the 1980s, it was visited by Voyager 1 and 2. And currently, the Cassini mission, sometimes called the Cassini-Huygens mission, is in orbit around Saturn and taking lots of pictures of Saturn, its rings, and its moons. Saturn's rings are very interesting. They make the planet one of the poster planets of the solar system. When you talk about general planet, you probably see a picture of Saturn, and there it is. Its rings have an interesting history. They were first noticed by Galileo, who I think referred to them as ears. Didn't quite know where they were. Again, Galileo happened to have an instrument that took him, his small telescope allowed him to see slightly higher magnification than the human eye. And just that slight magnification opened up a whole solar system of interesting things, that there were craters on the moon, that Venus had different phases, and that Saturn had something going on with it. Saturn had ears. It was later understood that Saturn had rings. The rings were first thought to be a solid sheet, some solid sheet of stuff, but then it was realized that even if you did make a solid sheet and put it around Saturn, that it would break up. And so that Saturn's rings are not one solid sheet. They are many, many smaller particles. One interesting thing about, how big are these particles? Typically, well, there's probably some really small sand-side particles. There's known to be pebble-sized particles, and the largest kind of particles you'll find in Saturn's rings are roughly car-sized. So there are lots of these things. Each can be considered a moonlet in its own way, but if you did so, you'd have to number, there'd be millions of them. You'd have to, there'd be trouble even naming them all. Saturn's rings are peculiarly, he said adeptly, razor thin, which means that they are several times the radius of the planet in diameter. They go out to 80,000 kilometers, yet they're maybe 10 meters thick. So the entire thickness of the rings could fit inside this classroom. That makes them, in a proportion, thinner than a razor blade. The rings, though, reflect lots of light. Some of the outer rings are probably puffier, the older rings. The age of the rings is under dispute. They're as young as 100 million years. They might have started when some moon broke up. They might have co-formed with Saturn. Recently, though, there's evidence that the rings of Saturn might be as old or almost as old as Saturn itself. One of the things is that Saturn's rings are almost purely water ice, and they seem to be relatively reflective water ice for most of the rings. And the wondering is, well, how can you do that with really old rings? Wouldn't they get dirty? But now people think they have some sophisticated mechanisms that might, in fact, do that, might create enough collisions or things to clean the rings and allow them to be very old. Sometimes the rings are shepherded by different moons. So the moons and rings can have interesting resonances. There's something called the Cassini division between the A and B rings. So the rings are labeled A, B, C, D. They used to be bigger, more important, the letters that labeled the rings years ago when that was all we knew. But now with the spacecraft that have been zipping by, we can see tremendous amount of detail. And breaking them into different ring letters is no longer as important as understanding attributes, physical attributes of the rings these days. So here's a picture of Saturn that you could not take from Earth, because when you look at Saturn from Earth, you're almost looking directly out from the sun. And when you do that, then the shadow of Saturn is almost directly behind Saturn. But here we see the shadow of Saturn is not almost directly behind Saturn. It's here off on the side. So this would be evidence that humans have left the Earth, or not humans, but spacecraft have left the Earth, something with the ability to take pictures. Here you see the rings have tremendous amount of detail. There's lots of ringlets and little ringlets and all different kinds of rings in Saturn's rings. Do we understand why there are all these little ringlets? No. It's so tremendously complex that we don't understand why. We know some of the physical attributes, we know some of the physical models that go into how they evolve, but all the little details as to why there's little gaps here and there, we don't know. It's just too complex. There's lots of things on Earth that are too complex to understand, even though we understand the physical processes. So one of the things I think of is when I'm driving in my car and I see here in Houghton in the winter and see a snow pile that's got different kinds of layers to it. There's probably a tremendous history of different plows that came by and different almost meltings and things like that that created that strange-looking pile of snow. So the physical processes may be understood, but just from looking at it, it would be very difficult to understand all the cars that went by and all the things that helped create that pile of snow. Well, the rings of Saturn remind me a little bit of that too. There's tremendous detail there. We don't know all the history that created all that detail, but we do know a lot of the physical processes that helped create it. Here's seasons of Saturn. Here you can see that when, so since the Earth is so near the Sun, again, when we see a part of Saturn, so this part of Saturn is undergoing summer here, the lower part, and the upper part is undergoing winter at the time that image was taken. But as you go closer to here, I think these are Hubble images, we can see that it's coming closer to the equinox of Saturn. Since the rings orbit in the equatorial plane, there are times, and it surprised people when this first happened. After the telescope was first invented, the first time that Saturn went through an equinox, the rings disappeared, which was really strange, because people were studying the rings and they seemed to be getting smaller and they didn't understand that. And then when the rings disappeared, that was really strange. Because of course the naysayers would come out and say, oh, Saturn never had rings. But it did, and once the equinox was over and once the tilt of Saturn was significant so that you can see the rings on the other side again, then they reappeared. Okay, so here you see the famous letters. This part of the ring is called the A ring. This is the B ring. This is the C ring. The D ring's internal. There's an E ring associated with a satellite we'll see later. Here's the F ring that I believe is shepherded by some satellites. Still useful for telling roughly what part of Saturn's rings you're talking about. Okay, here we have the A ring. So let's back up a little bit. So here we're talking about the A ring here. Here we see color-coded. This tells us a little bit about what's reflecting. So when it's more blue, I understand it's almost more pure water ice. And when it's more red, you can see that it's somewhat dirtier, because it glows more in infrared. And so there's more dirt on the ring particles that are red than the ring particles that are shown here in this false color image of blue. So again, what causes this, I don't quite know. There might be some episode in the past of the rings that we don't know, like there could have been some snowplow that went by that created some band of snow that we weren't there to watch. So again, this is done by the Cassini orbiter going around Saturn right now, discovering which rings are somewhat more dirty than others. And then planetary geologists and astronomers can try to figure out why that might be. Okay, here you see Cassini can cross the ring plane, and then the rings become very very thin, too thin to see. So here you see the moons moving around. So there's lots of small moons of Saturn. So here you move. Here the Pandora and Prometheus are actually shepherding this ring right there. So Mimas is here moving around. There's Mimas, if I can catch it. So now you're on the, so this side, I believe, Cassini, the spacecraft, is on the reflecting side of the rings. So in other words, the Sun and Cassini are on the same half of the rings. But now Cassini is transferred to the other side, and therefore the Sun is on the opposite side of the plane of the rings from Cassini. And it looks different. And you can see the moons go around as Cassini orbits and watches. Okay, here you can see one idea of the thinness of the ring plane. Again, the ring plane is even thinner than this. Here you can see a moon. Here you can see colors on Saturn. Saturn is more featureless in visible light than Jupiter. The reason for that isn't all that well known. Might have to do with a lower temperature. Here you can see something you don't see very much on Jupiter, which is the shadow of the rings. So the rings make significant shadows on Saturn. So the sun at the end, sunlight comes from this direction. You can picture the sun way over here. These things are blue light. Part of Saturn appears blue. And the reason for that is the same that part of Earth's atmosphere appears blue. It is preferential scattering of blue light from the atmosphere. Here the color of the atmosphere, I think, is more dominant. Strange thing discovered originally by Cassini. Cassini actually went a while without seeing these. But if you look at the rings, there are sometimes patterns there on the rings. And it shouldn't seem like there should be patterns, because these rings orbit like this and these rings orbit like that. And there should not be a lot of information. Shouldn't be particles bouncing between the rings. So that was a mystery. How can there be these changing, strange shapes called spokes on the rings of Saturn? And it is still not completely clear why, but it is thought now that it might have to do with electrical phenomena or electrical phenomena shot out by Saturn itself. So Saturn might be painting some kind of particles in electromagnetic, like lightning phenomena, possibly on Saturn itself, in the clouds of Saturn. It might be spraying out particles onto the rings and sort of painting the rings with these spokes. And then as the charged particles that may be there dissipate their charge as the rings rotate, then it goes away. So this was seen a lot by the Voyager spacecraft that passed Saturn. But for a while, it wasn't seen almost at all with Cassini. But now Cassini has seen spokes, and they are being studied, and they are somewhat mysterious still. Oh, this is a very interesting image. One of the images of the year last year for Astronomy Picture of the Day, picked by other people as images of the year too. This is Saturn, but it looks really strange because the sun is almost directly behind Saturn. So the sun is here, roughly. So Saturn, we are in the umbra. We are in the shadow of Saturn. So here this is a solar eclipse of the sun, a total eclipse of the sun by Saturn of Cassini spacecraft. So here you see the images, the rings. Here they are slightly deflecting light. Here you see an outer ring that's mostly dust that isn't so obvious from the other side. Here you see part of Saturn's atmosphere lit up by refracting sunlight. Here's an unusual dot right here. You see it? See this dot right there? Look closely. Who sees the dot? Anybody? Okay. You know what the dot is? That is Earth. So that's what Earth looks like from Saturn. It looks near the sun. It's this little point of light that moves around the sun. And it looks strangely blue, I'm sure, too, if there were aliens on Saturn that could. But that's all we are. We're a pale blue dot. Saturn's atmosphere. Similar to Jupiter's atmosphere, mostly hydrogen and helium, there are trace amounts of other elements. Saturn also rotates quickly, once in 10 hours. There are hurricane-like storms, but there's no great red spot. I don't believe there are any red spots that have ever been seen on Saturn, but there are like white spots. Some of the winds on Saturn are unusually strong. They're 1,800, put a little comma in there, kilometers per hour. So that's well beyond hurricane status here on Earth, although they would be much thinner higher up, and that's 4 times even faster than Jupiter. So the atmosphere of Saturn seems to have less features than Jupiter, and at times it's faster winds. Here you see Saturn rotating, and you can see the winds, some features on the planet go around. So let me go previous and next so we can see it again, because wasn't that fun? Saturn is not static. Here we see, I believe this was taken in infrared light, and you see some of the storms on Saturn in something called Storm Alley, because there were lots of them, and you can see some details there. So in some kinds of light, you can really start picking up some of the detail of Saturn's atmosphere. So Saturn has a very complex atmosphere. It's just not as easily seen, because it doesn't have some of the colors that make it very clear as Jupiter does. But if you look at it in the right colors and in sharp enough detail, you can see many storm systems, many bands and zones on Saturn. So Saturn's interior, like Jupiter, has no solid surface that we're aware of. It might have a core that's made of rocky things that might even be denser than the Earth, but it might be liquid, too hot. It's got a strange metallic middle. The atmosphere that we see goes only the top 1,000 kilometers or so, but it sort of melds into the liquid atmosphere, sort of, or liquid metallic hydrogen of Saturn. We know a bit less of Saturn's interior than Jupiter's. Saturn also radiates more energy, roughly twice the energy that's emitted from the sun, and the reason for that is they think that there are things falling inside of Saturn's atmosphere. So Saturn is still contracting. It's in a different phase than it was, I guess, when the planet formed initially, but parts of Saturn are still falling toward its center, and falling toward its center releases energy, and so that creates energy that's emitted. It has a magnetic field. B stands for magnetic field, but it's 20 times weaker than Jupiter. But it is still strong enough to channel auroras. So Saturn also has auroras. So let's have a look. Here you see auroras both on the north and south of Saturn. Here you see the rings. I think this is an infrared picture, and there's some particles of Saturn that aren't as well confined to the ring plane as others, so the rings here are a little bit thicker, but I think those are the rare exceptions. The bulk of the mass of Saturn's rings are much thinner. Here you see a picture from the Hubble Space Telescope of Saturn, and you can see the changing aurora at the poles of Saturn. Here it's an auroral ring. Again, there are particles that are surrounding Saturn that are hit by the solar wind or by a solar envelope coming out from the sun as part of a flare or coronal mass ejection. And these hit particles around Saturn and cause them to go into Saturn, but since they're charged, the magnetic field of Saturn has the most say. So the most magnetic field, it's free to move along magnetic field lines. It's hard to move across magnetic field lines, so they get channeled into Saturn's poles, where most magnetic field lines enter. So here we see, though, that there's the aurora change there. So a couple years ago, an unexpected finding around Saturn's south pole, in that there is a strange hurricane-like system. I think a couple of Earths could fit in here. And here's like the eye. And this thing has been going on for the duration of this. It's probably a long-lived system. It might be as long-lived as the planet. I don't think it's been photographed again since then, so we don't know how long-lived. But the south pole of Saturn is a very strange place. It looks like one huge storm system is there. So this was only discovered a couple years ago in everybody's lifetime. We're studying it, trying to figure out more about what goes on there, why there would be such a long-lived hurricane there, where there doesn't appear to be them over the other poles of Saturn or Jupiter. Why here? Thinking the North Pole possibly would be less strange, this is the North Pole of Saturn. And here you see a polygon. I probably might be missing it. I think it's 6 sides. Hexagon. So I think hexagon is 6 sides. And why it's hexagonal wasn't predicted, so it's not well known. It's easy to get circles in astronomy, which are projections of spheres. It's easy to get spheres because things like surface tension and gravity make spheres. How you get hexagons, less clear. It sometimes has to do with cooling. It's been seen for the past more than a year or so on Saturn, photographed by Cassini going over the poles. Again, this is false color. Why it's there, how long this particular feature is going to survive, not quite sure. Here's a picture in infrared light of, so neon Saturn, of Saturn taken in bands of light that aren't normally seen. I think it's infrared, and it might be the specific light emitted by some particles like neon, which are very much in trace. They're very much the exception. But here you can see, particularly in the north part of Saturn, in infrared light, there is hot and cold bands. Some bands are hotter than others, and if you look closely, you can see the hexagon pattern over Saturn's north pole. There are persistent electrical storms on Saturn. This one, like thunderstorms on Earth, electrical storms on Earth, has persisted for at least 3 months. So this thing goes longer than on Earth. It was being monitored. This was this year. It was found, and well, it's been tracked. And again, it might be that these electrical storms are related to the spokes on Saturn's rings. Still being studied. Moons. Saturn has a lot of moons. Some of them are quite strange. Titan is the most famous moon of Saturn. It is the only known moon in the solar system that has a thick atmosphere. So from the Earth, we haven't been able to see down through the atmosphere. And with the Voyagers going down, all they can see is that Titan was a fuzzy haze. Titan is by far the most massive of Saturn's moons. It's larger than the Earth's moon. There was, when the Cassini-Huygens spacecraft arrived at Saturn, Cassini released Huygens to go down to the surface of Titan and actually took images for a brief while from the surface of Titan, and I will show you those. Other moons, we'll get back to Titan. Other moons are Phoebe, which might be a captured comet, Dione, Enceladus, which I'll talk about, which surprisingly seems to be spewing ice or water particles into the solar system, creating a thin ring, possibly indicating that there is a subsurface ocean. Mimas and Rhea, some of which have old surfaces, and Hyperion, which is a very low density moon and has lots of empty caverns. Very strange moon. This is Titan in infrared light, where it shows this is just not there. If it shows, it's not known to be uniform. So if it's just, we just don't know. It hasn't been mapped when this image was there. So here you can see in infrared there are parts of Titan. Titan appears in optical light just to be relatively featureless. Here in infrared it has some features. It is thought that there is methane rain, hydrocarbon rain on Titan, and here you see this is not a picture taken from the surface, but this is an artist's impression. The artist is Mark Garlick. And here you see in this artist's impression there is a sea, and there are land features, and there's even lightning. This is an actual image from the descent of the Huygens probe toward Titan. It is going to a relatively dark region, which might have been a sea. You can see the highlands here that are lighter and higher in height. There, keep using that phrase. This is an image from the surface of Titan. Nothing like this had ever been taken before, I believe, 2005, when the landing took place just a few years ago. Here you see it is a muted world. It has what seems to be rocks. It has lots of rocks. It's got a horizon. It's just amazing to think that this is the surface of another world. This is sort of like Mars. Doesn't look that much different from Mars. The rocks here, though, are not thought to be rocks like rocks on Mars. They're thought to be water rocks. So these are ice cubes, in a way. Sometimes, I guess, dirty ice cubes. But so this image and others are still being studied because they are the only known images from the surface of this most unusual moon of Saturn. So this is an artist's rendering then. Based on what was seen, an artist then went back, pictured the probe itself. Here's the probe, what it might look like on the surface. Here is the parachute that allowed the probe to get down to the surface. And here are some of the water rocks that are seen along with the dirty soil. Sometimes when Cassini passes by the planet, it then maps with radar what is on the surface of the planet. And here you see parts of Titan that don't reflect radar very well. Almost not at all. So the question is, why is that? Why are the regions of Titan not reflecting radar? Well, these regions of Titan are probably like rocky regions of Earth, and they just have all kinds of surfaces to them in all directions, and so they're reflecting from the parts of Titan that are faced toward the radar beam. Though the dark parts might not. They might be a single uniform surface, and the single uniform surface or nearly uniform surface wouldn't have lots of bumps to reflect the radar. So it would be radar dark. So when you try to bounce radar off it, nothing's facing your direction to reflect the radar. So what can do that? And the thinking is some kind of sea. Probably not a water sea in this case. It might be a sea essentially of gasoline. There's a gasoline sea there of methane and things that if you had enough oxygen, you might be able to light on fire. Ethanol, ethane, methane. Not ethanol, that methane or ethane. Okay, out to Phoebe. This was one of the first satellites imaged by the Cassini spacecraft going in. It is has unusual craters and an unusual orbit, and so it is thought that this moon was captured by Saturn. This was just a comet made mostly of water ice, and it's been captured by Saturn and now orbits in a strange orbit. Some of Saturn's moons have very, very old surfaces, and by very old I mean lots and lots of craters. So here we have craters that are so old that they're not circular anymore. So when a crater forms, you get usually a circle because that's the shape. It doesn't matter what shape it comes in. It doesn't matter what the shape of the thing that hits it. When you have a crater, the crater is almost always circular. There's many things that make things form spheres and circles. So here, there's a shock wave that goes out, and the shock wave will go out in all directions at roughly equal speeds and create a circle, which is why craters are circular. If you make drops of, if you just take water and you throw drops on a surface, you will notice that regardless of the size of the drop, for small drops, regardless of the angle you threw those drops are pretty circular. And the reason for that is surface tension. So there's another thing. So nature seems to prefer spheres and circles. However, here we see things that aren't circular. Again, when you see that, something strange is going on. And the reason is thought that there's so many craters on Mimas's surface, Rhea's surface, that it's just old. And so things that used to be circular then get distorted. So here you see this has got a craggly edge. And here this one almost looks like a hexagon again. But it's not. There's not lots of hexagons there. It's just really old. There's craters and then craters and then craters. So this is a multi-billion-year-old surface that has been undergoing a lot of pounding. Here you see a relatively light area, a great white spot on Rhea, which also has an old surface. So this is probably a relatively recent crater that unearthed some of the lighter colored material underneath. The lighter ices came to the surface there. Enceladus, very exciting moon. It has what's called tiger stripes here. And out of these tiger stripes come fountains of particles, water particles. Probably they might be coming out as ice. They certainly freeze into ice crystals when they're outside. Unexpected. Makes Enceladus, again, maybe under the surface of this moon, there is a slushy ocean that has life in it. Maybe. So we can't show there's life there, but if we had to guess, one of the better likely places for life to exist outside of Earth and the solar system might be under the ice plains of Enceladus. Here is a picture taken looking at Enceladus practically back toward the sun. These have to be carefully taken because you don't want the Cassini spacecraft to look at the sun because it would burn out its detectors. But here you see there's stuff coming out here. There are plumes, there are jets coming off of Enceladus. And they're coming off pretty much all the time, and they're coming out of the Tiger stripes. So it makes Enceladus, previously thought to be not so exciting moon of Saturn. When we got there with Cassini, exciting moon of Saturn. Here we see the Enceladus is creating what's called the E-ring. So all this stuff, the moon actually is very hard to see. It's in the center there. Here you see some of the plumes coming right off, and here you see a lot of the particles, the ice particles, eventually spreading out along Enceladus' orbit and creating an entire ring that is now known as the E-ring. Okay, Dione has bright cliffs. Unknown why before. Well, they were bright white features before on a relatively dark moon. But now we know that these are mostly cliffs and fractures in the ice moon of Dione. Again, Dione is one of the few moons in the solar system, one of the few moons of Saturn, massive enough to make itself into a sphere. So gravity is creating that sphere. There's unusual cratering on Dione, and so here's some unusual craters. There are some parts of Dione that have lots more craters than other parts. And so one would think that, oh, I understand, the leading part of Dione is the one with the most craters, because Dione is locked to Saturn, and so only, just like Earth's moon shows half of its only half, the other half is always trailing. So that means that part of Dione always leads and part of Dione always trails. So which would be the most highly cratered part? Would it be the leading part or the trailing part? And we would have expected it would have been the leading part because that's where the very small velocity meteors would hit. But it turns out to be the trailing part. So we got that wrong. So why is it the trailing part? Not sure. Maybe there was an episode of collisions in the past that heavily caused a lot of cratering, and it didn't matter that those were moving so fast that it didn't matter. Or it could be that Dione was struck by relatively large objects that caused it to rotate, slightly, and then it got locked again. So maybe it keeps getting hit in its early period, particularly rotates some and then relocks itself to Saturn. Iapetus is a very strange moon. It has some very bright parts. It has very dark parts. It appears to be just at the edge where it's just massive enough to almost form a sphere, but it doesn't make it. So it looks strange. In fact, it looks like a walnut because it has a ridge, an unusual ridge there. If it was much more massive, the ridge wouldn't be sustainable. And like if you tried to make a mountain too high on Earth, it would fall down, and you can't make mountains too high on Earth. The Earth's gravity is too high. If you would make ridges too big on anything on Iapetus, maybe it's, if you tried to make it on Earth, it would fall down. But on Iapetus, the ridge of this size, the gravity isn't large enough to smooth it out. On Iapetus also has unusual black and white areas. So if we go previous, we can see that this is a dark area here, and there's an unusual light area. So if you go in and you zoom in on the light area, what do you see? And here's what you see. You see dark parts. There aren't holes in the planet, in the moon. They're just dark. There's some kind of dark, possibly called organic, but not from life-created having material there, having to do with carbons, carbon-rich material that makes it dark. And then there's light material that might have come from another source. It might be some sort of icy source. We don't know. But it makes for an unusual contrast. Okay, Saturn's Telesco is a very small moon, not massive enough to make itself into a sphere. It's unusually smooth. So here we keep taking pictures of stuff. Oh, we know what moons are like. They look like Earth's moon. They have lots of craters on them. They're locked to the planet. They have highlands and Maria, but no, the moons then in the solar system are looking way different from that. This one's really smooth. Why is it really smooth? Not completely sure. The best guess is that there's a very smooth regolith. There's lots of particles here. And these particles, so if you were to try to stand on this, you would sink in. And these particles have been shuffled around to make a relatively smooth coating all over the planet. However, the big craters can still be seen. Here's another one, another Shepherd moon. This one has more craters. It is also smooth. Shepherd moon means that it helps shepherd the rings of Saturn into sometimes very small rings. Okay, jumping off of Saturn now, going into the deeper solar system where I believe only one spacecraft has passed by Neptune. It was one of the Voyagers. I think Voyager 1. So Neptune is very similar to Uranus. Again, in the pairings of planets in the solar system, Earth and Venus have relatively the same size and mass. Jupiter and Saturn are relatively the size and mass. And Neptune is very similar to Uranus. So you can say, excuse me, but we'd be referring to the planet. So it is similar size, mass, and color. It has rings also. Its radius is, its distance from the sun is 30 astronomical units. An astronomical unit is the distance between the Earth and the sun. So Neptune orbits 30 times the distance from the Earth. It takes 165 years for Neptune to complete an orbit. Neptune is now the outermost planet. There's two reasons for this. One, the last contender for outermost planet, Pluto, used to be internal to Neptune, inside of Neptune's orbit. But in 1999, it crossed back out. So Pluto is on a very elliptical orbit, used to be closer to the sun than Neptune, now is not. But then, here on Earth, some people have declared that Pluto is now a dwarf planet and is not a real planet. This was voted, I think, 2 summers ago, a summer and a half ago, at the meeting of the International Astronomical Union, where they created a dwarf planet category and declared that Pluto was one of them. There's going to be another vote on Pluto's status. And in my opinion, although I'm a member of the International Astronomical Union, I'm unlikely to go and vote. I believe that Pluto should be re-included in a planet. I think that anything that's out in its own orbit that is massive enough to create a sphere out of itself should be a planet. But we'll talk about that next time. Back to Neptune. Neptune is colder and has more storms than Uranus. It's got more surface features on the planet. It also has a great dark spot. And strangely enough, unlike the great red spot, the great dark spot on Neptune that was seen, I think, by Voyager has disappeared. It's no longer there. So here you see at least the dark spot. Here is a lighter spot surrounded by a dark spot. So there are weather patterns on Neptune. It was Voyager 2, so I remembered which Voyager it was correctly. Here it is again. Great dark spot. Some kind of circulating region, most probably. This is 2 hours. Here you can see there's heights to these clouds. You can see shadows to the clouds. The sunlight comes down from the top. So this is 2 hours before Voyager 2 passed Neptune, 2 hours before its closest approach. So here it is in the most distant planet, the most distant large object in the solar system zipping by. What an adventure that must have been. Looking back, here you see Neptune and its large planet, large moon, Triton, both in crescent phase, looking back after it passed. So Neptune has a large moon. It's Triton, or Triton. It's like a Galilean moon of Jupiter. Saturn has a large moon, Titan, but I think Triton is even larger. It is not covered by much of an atmosphere, though. Uranus has nothing similar. Uranus does not have a large moon like Neptune does. Triton is thought to be 70% rock and 30% water ice. It's unusual in that it orbits backwards, so current thinking is that it was probably captured from elsewhere. So it didn't form near Neptune. It came near Neptune and was captured. It might have giant ice volcanoes, and it might have similarities to Saturn's Enceladus, but we don't know. And I don't think there's a spacecraft that's going to go close enough to really solve that. I don't remember for sure, but I don't think the New Horizons spacecraft that's going out to Pluto, I don't think that's going to be going near Neptune, but I can check on that. Here's an image, one of the few images of Neptune. Again, must have been taken by Voyager 2. We can't get anything like this from Earth. Hubble can't do it. The James Webb Space Telescope won't be able to do it. You can only get resolution like this by going really close. Here you see some grooves. Here you see some surely ice features on Triton. back to the original image. This is Hyperion. This is Saturn's moon. So it's unusual. It's not one of the more massive moons, but it looks like, strangely, like a potato. It has all these unusual holes. Are they craters? Probably, but why do they look so strange? And what's at the bottom of them? It looks like it is known that this is a very low density moon. So there's probably caverns. So if you could go caving, this would be one of the coolest places in the solar system to go. You could probably break into this moon and go through long caverns that go throughout the moon. It would be relatively low gravity too. But what are the dark things? The dark things are not holes into the center of the moon. They're dark regions at the bottom. What is it? What dark material is it that went into the craters of Hyperion? Don't know. Part of the mysteries of the solar system that continue. So we don't know everything. So now I'm going to go do the 7 astronomy pictures of the day. So let's exit this and go to here. So let's go to this. And we will start out by an artist's illustration of a close binary star system. I think it's about 300 light years from Earth. And here we see, let's see if I can go up just a little bit. It doesn't want me to do that. Here we see a binary star, 2 stars, and it seems from recent observations that this is a very dusty system. And how did such an old system have such a modern dust features? And one guess is that 2 planets that might have been roughly Earth-sized happened to collide. And this might have happened, let's say, if Earth and Venus collided. This would be something that would not make the newspapers because there would be no newspapers to publish. But this might have happened in the system BD plus 2307 and probably destroyed or created one superplanet, but also created lots of dust that went out and might have created the tremendous amount of dust that's seen in this system, this nearby system. All right, here's a cool picture sent to us, I think from Armenia. So here is a telescope in Armenia. Here, okay, here's a nice telescope, a relatively large telescope there. Clouds, lots of stars in the sky. Here is the planet Jupiter, I think. This was taken only a little while ago. The moon is over here, and the moon going through clouds gives something like crepuscular rays if they were from the sun, but they're created by the moon. So this is one of the, occasionally on APOD we like to show really cool pictures. So here was one. We've got a few of them this week. Okay, here's a relatively nearby spiral galaxy. So we'll be talking about spiral galaxies later in the course. Here you see clear spiral structure. This would probably be an SC galaxy. Lots of star-forming regions, mostly in red. Lots of dark dust regions. Central part that probably has a massive black hole in it. And so this, labeled M83, can be seen with a small telescope. It's also called the Thousand Ruby Galaxy, also called the Southern Pinwheel. So you need to see it from the southern hemisphere. Relatively nearby spiral. Okay, here we see a star-forming region called NGC 346 for a new general catalog, and this is in the small cloud of Magellan, which again, it's one of the satellite galaxies of the Milky Way, can be seen with the unaided eye from below the equator, and actually from parts slightly above the equator. So there's lots of stars forming here, and there's this big shell of dust. Again, not like the dust you would see around the apartment or your house, but dust that's more like cigarette smoke dust. Here's a tremendous amount of star formation that went on there in the small Magellanic clouds. So there's very intense episodes of star formation happening in the SMC, Small Cloud of Magellan. Okay, here's a place you can go to. I believe it's in Utah. There's this cave that you can look out over some of the mesas and buttes in Canyonlands National Park in Utah. And here are the mesas and buttes. So you're in this cave. Here's a stone circle called False Kiva. It's not known if it's an ancient circle or not. And in the background, you can see the Milky Way setting, and you can see the planet Jupiter. So this was taken just a little bit ago. It was actually hard to take this image. And I like the image because it's got different textures and features and things to see near and far. You can see things well in the distance, thousands of light years away. You can see things light minutes away in terms of Jupiter. You can see things just across the Earth, in the distance, and then you can see things that are close by, all in the same image. Recently, earlier in September, although we're on October 1st, earlier last month, particularly visible from the southern hemisphere, there was a grouping of the rocky planets. So we talked about the rocky planets before. Most recently, we've been doing the Jovian planets. So here you see some of the rocky planets. In fact, you see only 3 of the rocky planets there. Here's a young girl pointing toward them. So I believe this one's Venus. I believe this one's Mercury. I believe this one's Mars. And this is Spica. The 4th rocky planet is Earth, all down here. Which leads us up to today. So today is the 50th anniversary of the opening of NASA. And here you see a bumper rocket being launched from Cape Canaveral. It's the first launch from Cape Canaveral. You can see people taking images of that. It was an exciting launch. That was in 1950. 7 years later, the then Soviet Union launched Sputnik 1 and 2. They were the first satellites. In response, in 1958, 50 years ago today, the United States of America created NASA. And many of the images that we've seen today in this course and we will be seeing are taken by NASA. And it is a very exciting agency that I believe captures the imagination not only of the country that created it, but of the world. And it's teaching us a lot about our planet and our solar system and the universe. And with that, I will leave off until next time, when we will be going to smaller objects in the outer solar system. Talk to you then.